Okay, so for these next series of videos, we're going to look at various pathway applications for using Grasshopper, both whether it's starting with an original kind of footprint or even just using a center line for a pathway. So like I said, in this example, we're looking at if you draw just a basic footprint of some type of pathway or hardscape area, you can see that I've got this shape here. I've got this kind of imaginary landscape that it might be sitting on. So the idea is that we have some pathways opening up to a slightly wider pathway with a potential kind of lookout or seating area. We'll show more how this develops in other videos as well. So I'm gonna let's go ahead and turn off the landscape so we can just focus on this. So the first thing you want to do is start to apply some type of material. So I'm going to go ahead and reference my curve here. And what I want to do is start to apply some type of pattern. Again, I like to use the Lunchbox plugin. The panels give us a lot of options for different types of patterns that we could have. So one of the first things we can start to do is look at the kind of basic quad panel. This is basically going to create a grid of squares or rectangles, and you'll see that basically it's going to cover almost like the bounding box of this area, so it's not going to just stick within that footprint, and it's not really a huge issue. We can clean that up pretty easily. But just for now, we can use this to start to determine our style. So I can just start to maybe even go to a smaller one, or sorry, a larger value to get smaller sizes here. So this kind of, again, creates more of a square kind of pattern. If you want to go for something more of a paver look, we can use the staggered one. This one works really nice in terms of getting something to look kind of like those pavers. So again, I'll insert some high values here. So you can have them start to look kind of like that. If you want them to do the opposite, we can even try that. That could start to look, again, kind of interesting. Let's do another value here. So this is where we start to get that kind of level. In this case, maybe I want to try to get them looking almost square-like. So let's add some more values in the other direction. So let's keep this at like maybe 60. This one could be maybe 70. That might start to get these to look a little more squared. Let's try 80. Well, it's starting to look pretty good. Okay, so I'm not going to fiddle with it too much. But like I said, you can play with all sorts of different styles. And you can even stick with the kind of fun hexagon style as well. So let me just turn this one off. Again, you have a lot of freedom with these to create some interesting styles. So in this case, you could have these really kind of cool, really elongated hexagon patterns. Kind of looks fun. But yeah, so what I want to show you too is how you can, again, let me get rid of this one. It's kind of a boring one. Let's look at these staggered ones. Right, so what I want to do is start to trim away all that extra material. So what I want to do is actually convert these to curves. So I'm not dealing with surfaces, it's easier to trim these curves. I'm going to use the footprint curve to cut that away. So I'm going to use, in this case, the region intersection, and I'm going to have all my pavers to go into the A, so it's asking the first set of regions, and then here's the second set of regions, in this case our footprint. It's going to take a second. Should probably turn this off so we can actually see the results once it does it, but like I said, it's going to take a second. But I'll turn this off, and now we've got a nice, clean, trimmed pattern. And we can start to do some fun things with this, right? We don't want it to just maybe be kind of a standard panel. So what I want to do is I want to maybe use the corners as some type of parameter to begin to manipulate my pavers. So I'm going to go to the curves, use the control points, so control polygon. You can see this is going to, because I just drew these as nice clean lines, I can see that I only have the corners or points where there are corners. So I'm going to again use this to kind of dictate or be used as a parameter for this guy. So I'm going to use a distance logic to this. So I'm going to do area to find the points of all my pavers here, right? So I'm going to use the distance between this and these to basically create some type of scaling condition. So I'm going to go to vector, closest point. Again, these are the points I'm looking at. Here's the my points from here. And again, I'll show you what this is doing. Again, I kind of like to always use this as a cool visual of how this closest point is working. So basically it's just, again, associating all the points of my pavers with those corners and basically grouping them together like that, right? So we can see which ones are closest to which, and those are the ones that it's going to start to influence. So again, I'm not really going to need that. I just want to use that so I can kind of understand it a little better. So that's going to give me those distances for each one of those corners, and I can remap them to be used for scaling them. So in this case, I want them to start to get a little bit smaller as they approach those corners. So I'll find their parameters, and I'll just keep this to 0 to 1 because again, I like to use my favorite graph mapper component here to adjust these. So again, I want to scale these based off the proximity, so the closer they are, the more they're going to scale, and then as they get further away, they aren't going to scale at all. So I'm going to use the graph type, Bezier. So again, if it's really close, I want them to scale significantly, but I want them to only do it in a certain, for only a certain distance. So I'm going to create it like this. Now I'll use the scale component. Again, I'm scaling these curves based off of their center point, right? So it's just all uniform of a 0.5 scale factor. I drag this into there. I turn off all this. I can start to see how they start to shrink as they get closer to the corners. I can look at them a little bit better if I just use the surface component to plug into it, right? So this kind of gives you a better visual of what that might look like. Obviously, if you want that to still be something that can be walked on, you don't want to have that much of a gap. So I'm going to bump this up a little bit more so they don't scale as much. Maybe not as many of them scale. So if I want to, I could even kind of adjust my 0 to 1 because I know that I don't want them to probably scale more than maybe like 0.75, right? I don't want them to scale more than that. That's again gonna make the pavers almost unwalkable. So now it's actually, instead of that being 0, it's 0.75. So I can drag this up again to kind of get a little more variation, right? And if I want them to all have some slight spacing, a minimum, I could always say, you know what, I want them, instead of keeping their scale, it's 0.95. Okay. Right, so now there's always kind of a nice gap in between it, and the gap just starts to change more the closer they get to the corners. So maybe I want there to be a couple more so it's not so tight in those areas, and it actually looks like there's a difference happening. There we go. Maybe I can scale them a little bit more. Let's try 0.60. Yeah, that looks a little better, right? At least visually. Not necessarily pragmatic, but we're just trying to have some fun with these too. Okay, so now we've got some interesting pattern happening. Again, if the idea is some kind of interesting boardwalk, again, there's probably going to need to have some structural elements to this, and obviously even some depth. So I could even just begin to extrude these. And a distance, a z. Let's do something like 0.25. So if it's in feet, so at least 3 inches. I guess I could do 0.33 for 4-inch thick paver stones, masonry units. So this is going to take a hot second. Okay, but now I've got some actual pavers, or some volume to them at least. Right, obviously, and then I want to have them fill with something, so I'm going to just drop them down to 0.25 just so it doesn't seem too out of scale. Like I said, there's going to have to be something underneath it to support it, so you'd have to add that kind of structural element to it as well. But just moving on, again, with this being a boardwalk, we probably want to at least have some railings or some type of protective edge. So what I want to do now is start to do that. So from here, I can use, again, the footprint curve to do a lot of that. So I'm going to go ahead and, again, use I can use these points. Let's try it a couple ways. So again, I'm going to use this. I've got my points here, which I can use to help me out. Let's just try something though. So first thing I want to do is create the actual railing and as well as some of the post. So I'm going to look at this curve, and I know this is kind of something you have to be strategic with. Every one of these segments is either it's in intervals of 5, so it's either 5 or 10s, 20s, 30s, 50s, whatever. It makes it easy to keep your post evenly kind of spaced. So instead of having something like 7 and 12 and 32, like they're all just kind of weird intervals, these are all nicely drawn in intervals of 5 or 10. The narrow ones are 5, so I actually won't have a post if I do a point every 10 feet, which is nice. So I'm going to take this curve and I'm going to, I want to actually fragment it. So let's go ahead and shatter it. So here's the curve, and it also needs parameters. So I'm going to use these points to create that parameter. So I can use the curve closest point to get that lowercase t. It's asking for the points, which are here. Here's the curve, so this kind of helps us shatter it into these segments. So now they're actually segments instead of just one closed polyline. And so from here, I'm going to divide it by a distance of every 10 feet. You'll see that now I've got them nice and kind of equal distance from them for the most part in all the areas. Perfect. So, like I said, from here I'm going to go ahead and create the post for these. So I'll use these, I'll create a line SDL. The distance is going to be Z. I don't need them all to be graphed into different branches. They can all just be treated the same. The length, I want them about 3.5 feet tall. Right, so now here's my posts. I want them, instead of just being a curve, to actually be some type of post. So maybe I could just do a simple primitive, or actually I could just do surface and use the pipe. So it's asking for the base curve, the radius, and tells it how you want to do it. So here are our base curves, right? And then the radius, again, it's going to be something pretty low. So let's start off with 0.1, right? So that's the radius, so 0.2, or if I do something like 0.125, that'll at least give me a 3-inch wide pipe for my post. And then now I want to actually create the hand railing. So if you, let's just look at this real quick. So if you want, instead of using circles, you could always do squares. So I could do curve primitive and use the rectangle. So again, it's asking for that base plane, which is going to be at all of these points. And then you have to actually create a domain for your X and Y. So I'm going to just go to math, construct, domain. I'm going to basically use the same thing for both the X and the Y. And I'm going to use a 0.25. And I want one of them to be in the negative direction, and then one to be in the positive direction, so they're on center. So I have the slider just going into one, and then the negative going to the other. And again, that's the radius, so I can always shrink that a little bit more. And then I can just go ahead and extrude these with that same distance. Oops, sorry, it needs direction with the distance. So let's do Z with that distance. Oops, wrong distance, this one. There we go. So one was the pipe, here's if you want them to be squared. Let's make them slightly smaller. Okay, so now we want to add a handrail. Again, we could use the circle or the pipe. Basically what we could do is just take our base curve and move it in the Z direction by that same height. Alright, so there's that. And let's see what happens if I just decide to Alright, so there's my pipe now. Which is nice because even with the corners it actually fits into that. So maybe the radius of the pipe could be a little bit wider. Let's do 0.2, right? So now we've got our handrail. Pretty easy. We could even add, again, some kind of cross beams for our posts, which is always kind of fun. So again, I've got the line SDL, so I can basically say, you know what? Let's divide that curve by a number of points. And this is where you determine how many kind of cross beams do you want. I want something like 5 or 3 or something kind of low. And from here, I'm just gonna, again, kind of create the polyline curve here. And instead of them going that way, because it's just gonna basically recreate that, I'm gonna go to Sets, Tree, Flip Matrix. And now instead of them just creating a vertical line, it's gonna go from this line to that line to the next one. Right, so now here's my cross curves. And these are basically like, you could have it as like a cable or something. But again, it's pretty simple. What's nice too is knowing that this is on, the idea is that this is on a landscape. So that same process of creating my post here. So let's get rid of this one. Just keep everything nice and consistent. Is that I have them here. And this was created, again, slightly different. But I can take, let's do it this way. These are all being created from these points here. So I want to go ahead and project these points onto the surface. And again, I can reference my surface here. Let's turn that off. Now I'm going to connect it onto my geometry, so you can see now those same points are on my surface. So from those points and these new ones, again, they all have different distances, so I don't want to just extrude them up by a given distance, but I can create a curve based off of both these points. So there's the original points and these ones that I just projected down. So now I've got all unique curves. And so for the pipe here, what I basically want to do is, again, use the rectangle at the base of these. Right, so now it's there. I mean, it doesn't really matter. You could have it at the top or the bottom of it. So actually, I don't need it the line, but I can do the same idea of using the distance, right? So I need to extrude them in the Z direction. So again, I'm extruding my rectangle. See, like by default, they're all going to start to shoot up, which I guess they aren't clipping with each other. It's not that big of a deal. But what I could do is, you know what I actually could do is I could take these, no, it requires more work. So anyways, I'm going to extrude that distance based off of, again, where these original points are and these ones that I've projected down. So instead of using a line, again, I could do the line and then find the length and use that, but that's just one extra component I don't need. I can just use the distance between 2 points. So let me use this point and this point. So now I have a distance, and that's going to be used for my Z value. And now we can see that these just go, oops, it looks like that one just goes on almost for infinite distance. So for the sake of this, I'm just going to drop this surface down a little bit. There we go. So now it's kind of like your traditional boardwalk. I'm just going to try to turn off everything I don't need. So actually I need this one still. Don't need any of that. And there you go. So here's the pattern. Again, you'd have something underneath. It could be cool glass or something. If you want to use that other, instead of using these square pavers, it'll take a hot second again. But what if you want to use these ones? It's pretty simple, where all you have to do is plug this cell into this curve now. See, notice that the only thing that's coming out of this is this one line to here. So all I have to do is change this. And again, it'll take a second because it has to trim it, then it has to extrude the cells and change their scale and do all that stuff. But now we've got some kind of interesting interlocking hexagon look in those areas. I actually kind of like this one a lot. You can imagine maybe there's an underlying kind of grade underneath, so maybe some of the grasses start to come up. But it's cool how it all gets kind of nice and trimmed and extruded. So again, here's an example of how you can start to create a boardwalk using an interesting pattern. You can stick with the traditional kind of decking, or you can use another type of decking pattern or material.